Alrighty, this is hopefully an improved video on using the HackRF PortaPack with GNU Radio Companion to create a simple signal generator. And I have up here GNU Radio Companion, a script to do that, which just involves an Osmocom sync, which is our interface to the HackRF. A signal source to the left of it, set up with a sample rate of 10 megasamples per second, and then a couple of GUI controls to control the frequency and the RF gain out of this HackRF. So first we have to put the PortaPack into HackRF mode. So we scroll down here to HackRF, select that, and then turn HackRF on by selecting yes there. Now we're in HackRF mode. Now we can run this script. Just click this play button. And there we go. So now we are outputting a sinusoidal signal at 50 megahertz. That's the default value set up in that GUI slider. I'll show you in a second there. And I've got it set up with a output voltage peak to peak of 1 volt, which is a VRMS of about 370 millivolts. In order to get that level of output, we need to set up the gain at 34. As you can see right there on the slider, we have a gain of 34. As I've got marked here, the specification for the HackRF says we can get up to 15 dBm out on the transmit side. So we're in the transmit mode now. So if I go to the slider and I start cranking this up, let's see, I'll just keep going. 15 dBm, I have a chart here, 15 dBm would be 3.5 volts peak to peak and an RMS of 1.25. So let's see. All right. Keep going. I believe the number for RF gain here would be 47. There it is right there. The RMS of 1.29, a little bit high, and peak to peak of 3.3. And you can see that the sine wave is distorted. So I think the optimal use of this HackRF as a signal generator for a clean output signal is going to be at about, I believe it's 4 dBm, which is 1 volt. Peak to peak, right? So this is 2. Put that down to 34. So now we have a 1 volt peak to peak, VRMS of 370 millivolts, and you can see our amplification there is at 34. And if we bring up the, let's see, FFT, let's look at that. Right, so there's our signal at 50 megahertz, and it's it looks like on this it's saying a minus roughly maybe 8 dB. And then we have other spikes at minus 50 or below dBm. So it's not a perfect signal, but it's a pretty good looking sine wave. Out of the HackRF. So yeah, there you have it. So that's how you set it up. That looks to be about as far as you want to push the internal amplification of the RF signal out of the HackRF. This is the script. There's the settings to do that. And let's just crank up the frequency up to, say, 300 megahertz, which is about the limit of this scope. 70, 80, 90, there's 100 megahertz. You can see the HackRF is following along there. 170, 180, 190. Just have a closer look at this. Still looks pretty reasonable as a sine wave. 220, 250. There's 300 megahertz. And VRMS is, this could be partially the scope getting beyond its bandwidth. Down at 270 millivolts peak to peak and 94 millivolts VRMS. So that would be around minus 8 dBm. Anyway, and the sound wave looks pretty good. Alrighty, thanks for watching.